90. Let's go ahead and get started. Here we go. First of all, numbers 11 through 14 are a little difficult, but let's go ahead and see if we can't work on these together. Now, let's make these a little bigger, just a little bit. Hopefully we can do that. Alright, now, what we're going to do, please listen to me carefully, is we are going to look for, well, the directions. I'll just read the directions to you. The directions say to do the following. You are given the length and width of 3 rectangles. Which 2 rectangles are similar? So, we have this one here, and then of course the one over here we can't see. Now, 2 of those are similar, so we're going to start off by seeing if we can figure out which ones are similar. Now I know you see the underlined ones here in red, so you basically have the answers in front of you, and if you just look at that and write your answer down, you're doing nothing but hurting yourself. Please listen to the explanation, okay? We have a 4 by 5, and over here we have a 6 by 7. Now, from 4 to 6, there's one ratio, and the other one is 5 to 7. If I reduce both of those fractions, do I get the same fraction? Not even close. So let's try the other one, okay? We compared this one to this one. Now let's compare this one to the last one over here, okay? So we have a 4 by 5 triangle. And we have an 8 by 10 triangle. Okay, let's see if they're similar. 4 goes over 8, corresponds with 8. 5 corresponds with 10. If you reduce both of those, you get 1/2 and 1/2. So these, this dimension here is totally similar to this one right over here. Okay, alright, hope that made sense. Let's go ahead and continue on. Let's try the next one now, number 12. Alright, we have 3/4 and 9/4. So there's one dimension, 3/4 by 9/4. I think I'll go ahead and put all 3 of these up here. Then I have 1 yard by 3 yards. And then 7 by 13. Now let's first of all compare these two. 3/4 over 1, so 3/4 over 1, and then 9/4 over 3. Now let's go ahead and simplify these and see what we get, okay? We have 3/4 over 1 is 3/4. Now, be very careful here. Please listen to me, students. 9/4 over 3 just simply means 9/4 divided by what? 3. And 9/4 divided by 3 means 9/4 divided by 3 over 1. Then we're going to multiply, and we're going to flip this fraction, so it becomes 1/3. Well, 9/4 times 1/3 is 9/12. Reduce that and look at what you get. 3/4. So there we go. These dimensions here are similar. The rectangle that has these dimensions here is similar to this rectangle here that has these dimensions here. Okay? Alright, moving on. Let's take a look at number 12 or 13, number 13. Alright, here we go. We have 2 inches by 16 inches. So 2 by 16. Now be careful on this one. We have 1 foot by 9 inches now. We don't want feet and inches, so I'm going to make that 12 inches by 9 inches. Now we could have made them both feet, and that would have been fine to do, but you have a fraction here being 9 over 12, or 3/4 of a foot. So since I didn't want fractions, I converted everything to inches. So 1 foot is 12 inches and 9 inches. And then lastly we have meters and meters, so 4 by 3. Okay, students, here we go. Let's go ahead and get started. Let's go ahead and compare these dimensions to these dimensions. 2 corresponds with 12. 16 corresponds with 9. If you reduce this, you get 1/6. You cannot reduce this, and you do not have 2 equal fractions. So I know for sure this rectangle and this rectangle are not similar. Okay, now let's try this one here and this one over here. So 2 over 4 equals 16 over 3. No way, they're not equal at all. Not at all. So I know this rectangle here is not similar to this one here. So the only option I have left is comparing this one here with this one here. Let's see what happens. 12 corresponds with 4. 9 corresponds with 3. Reduce 12 fourths, you get 3 over 1. Reduce 9 thirds, you get 3 over 1. They're equal. So yes, these two here are similar rectangles. These are the dimensions of rectangles that are similar. And the last one, number 16 or number 14. Okay, we have 50 centimeters and 1 meter. Now be careful here. I could make 50 centimeters a meter, but it would be a decimal. It would be a lot easier to say 50 centimeters by 100 centimeters because 1 meter equals 100 centimeters. So I'm going to make them both centimeters. Now over here I have inches and feet. Once again, I'm going to make everything inches. So 3 inches by 6 inches because a half a foot is 6 inches. And then over here we have centimeters and centimeters. So 6 by 1. Okay, well, let's start with these two right here. Let's put 50 over 3. Let's put 100 over 6. You cannot reduce this fraction here, but you can reduce this one, and it reduces to, look at that, 50 over 3. So these two fractions here are equal. They do equal each other. So these two dimensions of the rectangles, these two rectangles that have these dimensions are similar. They are similar. Okay. All right. Moving on to number 15. 15 through 18. Now the directions say to sketch the indicated polygon if possible. If not possible, explain why. Okay. Two isosceles triangles that are not similar. Sure, guys, it's a piece of cake. Remember. In order for polygons to be similar, they must have congruent angles. So draw an isosceles triangle that looks like this. This side's congruent to this side. And then draw one that looks like this. There's no way this angle here, that you have 3 angles here, congruent to these 3 angles over here. Okay, so yes, it's totally possible. Number 16, is it possible to draw 2 congruent rectangles that are not similar? No, of course not. No, let me explain my reasoning to you. If they're congruent, then their sides will be proportional. Think about it. Okay, here's a rectangle. Let's say we have 5 and 2. And we have all right angles. Here's another rectangle over here. It's congruent. So 5, 2, all right angles all the way across, okay? Well, look, this side corresponds with this side, 5 over 5. This side corresponds with this side, 2 over 2. 5 over 5 is 1, 2 over 2 is 1. They equal. That's always going to happen, guys. If the two figures are congruent, then they're also similar. Now, the converse of that is not true. If two figures are similar, they might or might not be congruent, okay? But if two figures are congruent, then they're also similar, yes, definitely. Okay, number 17, 2 similar isosceles triangles that are not congruent. Well, sure, no problem. Here it is right here. We'll call that an isosceles triangle. I think we will anyways. Let's see if we can. There we go, it's better. So there's an isosceles triangle, okay? Now, I'm going to take this one here. I'm going to shrink it. There we go. We're going to say this angle is congruent to this angle, and this angle is congruent to this angle, and we could say the sides are proportional. Yes, you can definitely draw 2 similar isosceles triangles that are not congruent. Definitely. Alright. Okay, number 18. 2 squares that are not similar. No, that's impossible. Any square that you draw will be similar. Do you know why? Let me show you why. Here's a little square. Let's say all the sides are 3. Here's a big square. Let's let's say all the sides are 8. Well, if all the sides are same, 3 corresponds with 8. 3 corresponds with 8. 3 corresponds with 8. 3 corresponds with 8. You're always going to get out 4 equal fractions. I don't care what the two squares are. Their sides are always going to be proportional, because look, this side over this side will always be the same as this side over this side, because all 4 sides are the same and all 4 sides are the same. So is it possible to have two squares that are not similar? No. All squares are similar. Okay, moving on to numbers 19 and 20. The directions say to determine whether the polygons are similar. If they are, find the scale factor of A to B. Okay, well, first of all, students, excuse me for yawning. Yes, these two here will be congruent. Okay. Whenever you have now listen to me carefully, students. Whenever you have a quadrilateral in which both sets of opposite sides are congruent, you then have a parallelogram. And if you have a parallelogram, you know this angle is congruent to this angle, and you know these two angles here congruent to these two angles here. Now, over here, remember, anytime you have a quadrilateral in which both sets of opposite sides are congruent, then you have a parallelogram, which means these opposite angles are congruent. So this angle is congruent to this angle. This angle is congruent to this angle. Opposite angles are congruent. And we know when you have a parallelogram, these two angles here have to be supplementary. So I know whatever this angle is here, let's say this is 50 right here, then this has to be 130. And if this is 50, that's 50, then this has to be 130. So because these two angles are congruent, then this angle here would also have to be congruent, and so would this one here. Okay, so yes, we definitely have similar polygons. And you say, well, Mr. Garrett, the angles are congruent. What about the sides? Well, I mean, look, guys, we have congruent sides all the way around. So put a 6 here, a 6 here, and a 6 here. We have congruent sides all the way around, 4, 4, and 4. So you'd have 6 over 4 equals 6 over 4 equals 6 over 4 equals 6 over 4. Now, what is the scale factor? It says the scale factor of A to B. So start with A, take your 6, and then go to B. The scale factor of A to B is 6 over 4. Now reduce that, and the scale factor is 3 halves. Okay. Now number 20, we're going to have non-similar polygons, and let me show you why. It is true that we have an isosceles trapezoid here. This side's parallel to this side, and this side's congruent to this side. Same thing here, isosceles trapezoid, okay? So, what we don't know, though, guys, listen to me. Just because they're both isosceles trapezoids, that does not mean we know for sure this angle here is congruent to this angle over here, and this one is congruent to this one here, and this one here congruent to this one here, and this angle here congruent to this angle here. We don't know that for sure, okay? Because we don't know what these angles are. So if you don't know for sure that the angles are congruent, then you cannot state for sure that they're similar, okay? So we're going to say not similar. Alright, moving on. Now, numbers 21 through 26, they want us to say always, sometimes, or never. So here we go. Regular hexagons are always, sometimes, or never similar. Well, if they're regular, think about it, guys. Yes, they're going to always be similar. Let me show you why. Okay? If you have a regular hexagon, all the sides are congruent, and then you have another regular hexagon. Remember, regular means all the sides and all the angles are congruent. Okay? So, all of the angles here have to be congruent to these over here, and all of these sides have to be proportional. Remember, these angles on the inside can't change if it's a regular hexagon. We know that because we know that the sum of all these angles right here, we know to find the sum of all the interior angles would be 180 times n minus 2, 6 minus 2, 4, 720. So we know if we add up all 6 angles, we get 720. And now you simply divide by 6, and you get 120 for each one of these angles, which of course would be the same over here, 120 for each angle. So the sides have to be proportional. They have to be, because look, pretend this was a 3, this was a 7. Well, if this is a 3 here, then this has to be a 3 here, that's a 7. Then this has to be 7 right here, because it's a regular hexagon. So 3 over 7 equals 3 over 7. And you can go around the whole figure, but it's going to be 3 over 7, 3 over 7, 3 over 7. So yes, they are always similar. Number 22, similar polygons are congruent. Well, remember we just talked about this a little bit ago. Congruent polygons are always similar, but similar polygons are not always congruent. So sometimes similar polygons are congruent. Number 23, congruent polygons are always similar. Yes, if they are congruent, they will be similar. So congruent polygons are always similar. Okay, number 24. Right triangles are similar. Well, obviously that's not always going to be true, because I can draw a right triangle that has, I don't know, 45 and 45. Then I can draw a real skinny right triangle that has 80 here and 10 degrees up here, and they're both right triangles. Remember, for two polygons to be similar, their angles have to be congruent. So, is it possible? Yes, it's possible. So the answer is sometimes. But you can't say always. You cannot say it's always true that if you have two right triangles, that they're similar. Okay, number 25. Equilateral triangles are always going to be similar. They are going to be similar. Yes, always. Because they're equilateral triangles. Now, come on, guys. That means if I have a 3, a 3, and a 3, I've got a real big one over here, and an equilateral triangle, let's say it's an 8, an 8, and an 8. Well, we know there's 60, 60, 60, 60, 60, 60. We know that all equilateral triangles are also equiangular. So the angles are taken care of. Now, if I put this side over its corresponding side 3 over 8, and then I would put 3 over 8, and then I would put 3 over 8. Okay, there we go. So, as we see, if you have equilateral triangles, they will always be similar. Okay, number 26. A square and a rhombus are similar sometimes, but not always. I can think of times where you have a square, which is all 4 at 90-degree angles, and then a rhombus looks something like this, and the angles are not congruent to a square. Okay, the square is going to have 4 right angles over here. Now, it's possible it could happen, definitely. So I'm going to put sometimes, but it's not always or never. Alright, moving on to numbers 29 and 30. Numbers 29 and 30. Okay, now look what we have up here, students. ABCD is similar to PQRS, okay? If the ratio of the perimeter of ABCD to the perimeter of PQRS is 4 to 3, what is AD over PS? Now, come on, guys, look at this, please. AD over PS means side AD over side PS. Now, we learned theorem 8.1, okay, in the video. It says that if two triangles or if two polygons are similar, then the ratio of the perimeter will be the same as the ratio of the sides. So if I know the perimeter of these two similar triangles, if I know the ratio of the perimeter is 4 to 3, that will also be the ratio of any side put over any side, okay, because they're similar. Number 30, SR over CD equals 3/4, and the perimeter of PQRS is 10. What is the perimeter of ABCD? Alright, let's be really careful here. First of all, we have now it would be best to go ahead and get a picture of our two figures. So real quick, A, B, C, D. And I'm not worried about drawing these to scale. P, Q, R, S. Now look, SR, we're going to call that 3. CD is 4, okay? So here we go. The ratio of SR to CD is 3 to 4. Got it? Now, notice I went from this rectangle triangle is 3/4. Remember, we had a theorem that said the ratio of the perimeter of two similar polygons will equal the ratio of the proportional sides. So here's your two sides, SR and CD, SR and CD, and we can see that their proportion is, or their ratio is, 3/4, which means that the perimeter, we're going to call this perimeter 1 and perimeter 2. That means the ratio of the sides is 3/4. So the perimeter going from here to here is going to be 3/4 also. Okay, so here's what I have. I have 3/4. Okay, that's the ratio of the perimeter going to this way. And then the perimeter of PQRS is 10, which is this right here. This parallelogram has a perimeter of 10. So I'm going to put a 10 right here. And then here's my X. Okay, let's go over this again. The ratio of two sides of similar polygons will equal the ratio of the perimeters. So if this is the ratio of the sides, it's also the ratio of the perimeters. 3/4 equals 10/x. Cross multiply 3x. Cross multiply 40. Divide by 3, and we get 40/3. Okay, which is the correct answer. Okay, number 36. The directions for 36 and 37 say to do the following. The two polygons are similar, solve for x and y. Okay, so here we go. Let's write a bunch of fractions. Okay, we know that 6 corresponds with x minus 2. We know that 10 corresponds with 15. And we know that 8 corresponds with y plus 3. Okay, so let's go ahead and use these two fractions first, and let's solve for x. Okay, so 6 times 15 is 90. 10 times x minus 2 is 10x minus 20. Add 20 to both sides, 110 equals 10x. Divide both sides by 10, 11 equals x. So there we go. We know that x equals 11. Now, to solve for y, let's use these two fractions right here. Okay, so 8 times, because I'm solving for y now, 8 times 15 is 120 equals 10 times y plus 3 would be 10y plus 30. Bring the 30 over and make it negative. That leaves you with 90 equals 10y. Divide both sides by 10, and 9 equals y. X equals 11. Okay. Let's go ahead and take a look at the last one here, number 37, and we're finished. Now, remember, they tell you in the directions that the two polygons are similar. Also, we know we have a parallelogram here because we have both sets of opposite sides are parallel. We have a quadrilateral in which both sets of opposite sides are parallel. Now, when it comes to parallelograms, that means opposite angles are congruent and consecutive angles are supplementary. So if that's 70, this has to be 110. They add up to 180. This has to be 110. Okay. Now, let's go ahead and solve for angle y. Angle y would be 110 degrees. See it? There it is. So y equals 110 degrees. Okay. Because we know the two parallelograms are similar, that means the angles have to be congruent. So that's why if this is 110, I know this has to be 110 also. Now, let's solve for x, okay? Let's see what we know here. If this is 12 here, now 12 corresponds with this side here, which doesn't help me, but hold it. When you have a parallelogram, opposite sides are congruent. So if this side is 12, then this side here is 12 also. So now I can say 12/8 equals, and then 16/x plus 2. Okay, and now we're ready to solve for x. So here we go. 12/8 equals 16/x plus 2. 8 times 16 would be 128, I believe. Let's see. 12 times x plus 2 would be 12x plus 24. Bring the 24 over and make it negative, and we're left with 104. Now, that doesn't look right. Let's see if we get, yeah, we are going to get a fraction. Bring the 24 over and make it negative. That's 104 equals 12x. Divide both sides by 12, and we get 104/12. Let's reduce reduce that. 2 goes into both of those. 52 over 6 will reduce again. 26 over 3 equals x. Okay, 26 over 3